Here we're going to look at question 6 of the ENGAA 2018 paper. This question begins by giving us some information on visible light. It begins by telling us that in a vacuum, visible light has a wavelength between 400 nanometers and 700 nanometers. The question then tells us that in a vacuum, light has a speed of 3 times 10 to the 8 meters per second. Finally, the question gives us a series of statements on ultraviolet light, all stating that it has a maximum or minimum frequency of some number of hertz. The question then asks us which of these statements is true. So essentially, it's asking us to find the maximum or minimum frequency of ultraviolet light. So let's go ahead and try and think about what equations we could use to solve this problem. Now we're asked to find a frequency of ultraviolet light, and we're given some wavelengths and a speed. So an equation that you should perhaps know is that the speed of a wave, c, is equal to its frequency multiplied by its wavelength. Therefore, we can go ahead and rearrange this to get that the frequency of a wave is equal to its speed divided by its wavelength. So, if we want to find the maximum or minimum frequency of ultraviolet light, we need to find its minimum or maximum wavelength. Then, substituting this in with the speed that we've been told of ultraviolet light, we should be able to find the maximum or minimum frequency. Now in this question, we've been asked about ultraviolet light, but given information about visible light. So, to see how the two relate to one another, let's try and look at the light spectrum. So, this is a diagram which should be quite familiar to you by now. If not, it's fairly easy to learn. It's just the 6 different names for different wavelengths and frequencies of light. So it goes from radio all the way up to gamma. Now, gamma is the most energetic form of radiation of light, and this has the shortest wavelength. Radio, on the other hand, has an extremely long wavelength and is nowhere near as energetic as gamma radiation. If we look towards the middle of our diagram, we can see that we have visible light right next to ultraviolet light. And we see that ultraviolet light has a shorter wavelength than visible. Therefore, the longest wavelengths of ultraviolet light shall coincide with the shortest wavelengths of visible light. Since we've been told that the shortest wavelengths of visible light are about 400 nanometers, then this 400 nanometers should be the highest wavelength of ultraviolet light as well. So we can go ahead and substitute this value of 400 nanometers into our equation for the frequency of ultraviolet light. But how do we know if this frequency is the maximum or minimum frequency of ultraviolet light? Well, we know that this 400 nanometers is the longest possible wavelength of ultraviolet light. So all of the other wavelengths shall be shorter, so our denominator of our equation shall get smaller. When the denominator shall get smaller, it means that our frequency shall gradually increase. So this wavelength, 400 nanometers, must be the minimum frequency of ultraviolet light, since for all other wavelengths of ultraviolet light, the frequency shall increase towards a maximum. So, now that we know that we're looking for the minimum frequency of ultraviolet light, we can go ahead and try and calculate a value for this. So, from the equation that we wrote down previously, we know that the minimum frequency is going to be equal to the speed of ultraviolet radiation, that is, the speed of light in a vacuum, divided by its maximum wavelength, which I here have converted into standard form, so it's going to make it a bit easier to do the calculation. Now, through sheer abuse of notation, we can go ahead and write this as 3 over 4 multiplied by 10 to the 15 hertz. Now, the 10 to the 15 hertz comes from the fact that we have 10 to the power of 8 divided by 10 to the power of minus 7. So we take our power of 8 and take away the power of minus 7, leaving 10 to the 15, and the 3 over 4 we can simplify in the next step. So we know that 3 over 4 is just 0.75, which we can then go ahead and turn into standard form as 7.5 times 10 to the 14 hertz. This corresponds to answer G, and we finished our question.